This is a recast of the 5,600-word piece, Distribution of Gold in Igneous Rocks, from academia.edu. Let's listen in.
The article we're talking about today is a geological survey paper about the distribution of gold in igneous rocks. This study was performed by scientists David Gottfried, Jack J. Rowe, and Robert I. Tilling.
They analyzed approximately 700 igneous rocks, representing diverse magma types from different geographical areas and tectonic settings. The gold content was determined by neutron activation analysis combined with fire assays for the radiochemical separation of gold.
For those new to this field, neutron activation analysis is a method that relies on the measurement of radiation from radioactive isotopes. In this case, it was used to measure gold content in rocks with high sensitivity, making it ideal to study gold in igneous rocks at low concentration levels.
In terms of results, the researchers found that the gold content in most plutonic rocks, especially those from calcocalic provinces like batholiths of the western United States, varied little, with the majority having no more than 3 parts per billion of gold.
Interestingly, though, the Southern California batholith was an exception. It had some gabbroic and tonalitic rocks containing as much as 10 parts per billion of gold. Plutonic rocks from alkalic provinces generally had low gold content.
When it comes to volcanic rocks, basaltic rocks were examined including tholeiitic, low potassium oxide, high aluminum oxide, and alkalic basalts. Alkalic basalts appear to have lower gold content compared to most Hawaiian and continental basalts of the tholeiitic magma type.
The paper also mentioned the accuracy of their method and gave an example of an experiment to explain contamination effects. They found that handling samples with fingers that have touched gold can significantly increase the measured gold content in the samples.
A key takeaway from this study is that it provides valuable data for establishing the crustal abundance of gold. Its findings are particularly useful in defining potential sources of low-grade ores and understanding the geochemical behavior of gold in magmatic processes.
The researchers also pointed out that these results are primarily useful for geological research, rather than for locating new sources of gold deposits for mining. They emphasize the importance of geologic factors like petrologic, structural, and tectonic setting alongside pure geochemical abundance factors when exploring for gold.
That's it for today.